Hello, my name is Tessa Petersell, and I am part of the Neuromechanics and Applied Locomotion Lab at the University of Utah. And today we'll be looking at the association between computerized neurocognitive testing and reactive balance. Recovery timelines after concussion differ between neurocognitive performance and postural control. Many deficits can be seen after sustaining an MTBI, including reaction time, memory, balance, and cognitive function. Generally, reaction time deficits can return back to baseline levels 14 days post-MTBI. However, this is only for motor control. In the postural control, we see that in many cases, it takes past this 14-day timeline in order to return back to those baseline levels. This means that the two different indices are difficult to compare because they have different timelines of recovery and thus indicate that the mechanism of recovery might be different. The relationship between computerized neurocognitive reaction time and reactive balance is unknown. While static and dynamic balance are currently assessed in current concussion testing, reactive balance is different from both static and dynamic balance, and it isn't currently being assessed. Both computerized reaction time and reactive balance require the input of a stimulus and then an immediate response. However, the mechanism of these responses is different. In a neurocognitive computerized reaction time, you'll be presented with your stimulus and then be required to respond discreetly and quickly. However, in a reactive balance test, your stimulus, or in many cases, a perturbation, will be applied, and then you're forced to integratively respond to the environment and cues from yourself in order to regain your balance after being put off balance. But once again, this is a very integrative response and it doesn't have a simple discrete response. So the neurocognitive computerized reaction time and reactive balance test are different. In our study, 197 collegiate athletes completed both a reactive postural and computerized neurocognitive test. The reactive postural test we utilized was the push and release. In this test, the athletes perform it in 4 different directions: forwards, backwards, left, and right. They do this under an eyes closed condition and in both the single and dual task. In order to perform this test, the athlete will lean into an administrator's hands, and the administrator will lean them back so that they are off of their center of balance. Then they will close their eyes, and after an unexpected amount of time, the administrator will remove their hands. This requires the participant to take a reactive step in any direction in order to regain their balance. The only difference is in the dual task condition, when they're leaning back into the administrator's hands, they will perform a cognitive test. An example of this might be counting backwards from 7 by a predetermined specified number. Our computerized neurocognitive test we used was the IMPACT. The IMPACT assesses many different cognitive deficits after MTBI, and it assesses reaction time. So you can assess deficits in reaction time as well. There are different stimuli and response executions between the two tests. For example, in a computerized reaction time test, we use a visual stimulus, but in the reactive balance test, we use a proprioceptive or vestibular stimuli. Additionally, there is a single-digit simple response from the computerized test, and in the reactive time test, in the reactive balance test, there is a whole body integrative response. What I mean by this is that when the stimulus is presented in a computer test, a simple digit click on the keyboard or on the mouse pad may be enough to respond to the stimuli. However, with your postural control test, once you are pulled off balance, you require a leg movement, maybe a hand movement, a whole body integrated response in order to respond to this stimuli. The latency values that we utilized were calculated via MATLAB using data from IMUs. We calculated latency as the time of release from the initial movement of the first stepping foot on the athlete. This can be calculated as the release time is taken from the wrist sensor on the administrator, and the latency time will be at the point in which the accelerometer reads the initial movement of the stepping foot. You can see the release point is indicated by the first arrow in the figure, and the second arrow in the figure indicates the initial movement of the first stepping foot. The time/distance between these two is the latency value that we used. Here are results. Postural response latency was not associated with computerized neurocognitive measures. As you can see in our correlation matrix, we have scatter plots of comparisons between each of the indices from the impact test to both single task and dual task latency values of the push and release in the forward direction. All of these values being so small indicate that there was not a strong association between any of the indices. Another additional piece of information that is interesting is that the dual task, which includes a cognitive function test, didn't show any differing results between the single task and the dual task in comparison to all of the impact matrices. The significance of this is that computerized neurocognitive testing may not be capturing deficits in reactive balance control. Think about some sport-specific responses. When an athlete is in game time situation, they aren't going to only be presented with a visual stimulus. They're going to be presented with vestibular, proprioceptive, visual, all at the same time, or each individual at separate times. If the computerized neurocognitive test is only assessing a visual stimuli, then it might be beneficial to input a reactive balance test to these current assessments. Additionally, the mechanisms of integration for the two are different. So we see that in our computerized test, we require just a simple single-digit response. But in game time, there won't be a situation in which only a single digit is needed to respond. The whole body needs to respond. Therefore, if we are not assessing athletes to be prepared to go back into the game at return to play timelines, then we are potentially putting the athletes at risk when they go back into the game. So there are limitations to this study. We are unsure about the clinical implications of a reactive balance test in current guidelines. However, due to the differences of the sensory inputs, the mechanisms of integration, and the need for an athlete to respond in sport-specific situations, input of reactive balance tests to current assessments might be a beneficial thing to add. Thank you to everyone who helped out with this project. Hope you guys enjoyed.